Hi everyone, my name is Hasto. In today's video, we dive into the Soroban and Flutter code I used to build the Cowchain Farm smart contract. Before we jump into the details, just in case you missed it earlier, Cowchain Farm is a smart contract app built using Soroban on Stellar blockchain and using Flutter as the front-end framework. We'll cover the Soroban code first. After that, we'll cover a bit about the Flutter code. No need to delay any longer. Let's get right into it. In this interface file, we can see the traits that have the function that will be implemented in the Cow contract. Let's start with the init function. This is the first function that we should call after deploying a contract. The purpose of this function is to store admin and native token addresses to be used in other functions, and to extend the storage instance lifetime to the next 50 weeks. These functions require a password to ensure the identity of the contract initiator, and this is so that no one other than us can initiate it. The use of this password can be replaced by using a deployer contract, but for this time, I choose to use a password. Next is the upgrade function. So each time we deploy a contract, we will get a different contract address. In some cases, this has the potential to cause problems, because every time we deploy a contract for a new version, we have to migrate user data from the old contract address to the new one. This is where the upgrade function comes in handy. We can deploy the latest contract version using the old contract address. This is so cool, right? Next, there is the bump instance function and the health check function. The bump instance helps extend the storage instance lifetime on our contract. And for the health check, as the name implies, determine if our contract is still alive or has expired. Now, we will talk about the buy-cow function. This function requires authorization from the user account. This is because the user will transfer XLM tokens from the user account to the contract account to purchase the cow. Before making any transaction, this function will do all necessary checks. Start from checking whether the contract has been initiated, or does the user have enough balance to make a purchase. If all checks are passed, the contract will start carrying out activities such as token transfer, storing user data in persistent storage, and storing cow data in temporary storage. Finally, the function will return the buy cow results charge to the function invoker. The following function that we will discuss is the sell cow function. Just like the previous function, the sell cow function requires user account authorization. These functions also perform all necessary checks, especially checking whether the cow to be sold is still alive, or if the cow is old enough to be sold. After all checks have been passed, this function will delete the cow ID from the list of user ownership in persistent storage, and also delete the cow data in the temporary storage. Finally, the function will return a sell cow result charged to the invoker. Next is the cow appraisal function. When we do sell activities, before calling the sell cow function, the function that is called first is cow appraisal. This is because we need the user's approval regarding the cow's selling price. This function will estimate the price based on the feeding performance of the cows. A cow that constantly fed on time will increase its price, while cows that are late or even forget to be fed, the price is more difficult to increase and even tends to decrease. The last two functions are feed the cow and get all cows. Feed the cow is a function to update statistical data on cows' feeding activity, and also to extend the life of cow data in temporary storage. This statistical data will then be used to estimate the cow's selling price. Lastly, get all cow is a function to get all cow data owned by a user. This function is usually called when the user logs in to the website. In addition to functions, Cowchain Farm contracts also use constants, enums, and custom types. Existing enums including data key, status, and cow breed. For a custom type, an example is cow status. Cow status has status property with the enum data type and a ledger property with the 32-bit unsigned integer data type. Cow status also has a new method to make it easier to create the cow status charge. Those are the Soroban codes used to build the Cowchain Farm smart contract. Some concepts and fundamentals from Soroban still haven't been applied to the smart contract. You can find out more by visiting the official Soroban website at soroban.stellar.org. Now let's talk a little bit about Flutter code. There are two things I want to discuss. The first is how to call the Flutter extension from Flutter. The second is submitting our transaction to FutureNet and receiving the custom type data from smart contract. Let's start with the first. On the screen, we can see that there are three files open. There is Flutter helper, jsinterop, and cow.js. These three files play a role in calling the Flutter extension. As an example, let's discuss the function isConnected. This function uses isConnected callback and calls the Flutter isConnected function in the jsinterop file. The function and callback in the jsinterop will then communicate with the function and callbacks in the cow.js file. The function and callback names in these two files must be the same. Otherwise, we cannot call the Flutter function on the JavaScript side. Once the Flutter function is successfully called, the resulting data will be returned via a callback to Flutter. Now we discuss the second part. Submit transaction to FutureNet and receive the result. When we send transaction to FutureNet, two essential things must be considered. First is the name of the function being called. The function's name must be the same between the code in Flutter and the name in the smart contract. Second is the order of the arguments needed by the function. If we look at the code in the smart contract, the order of argument is user address, cow name, cow ID, and cow breed. The order of arguments on the Flutter side should also be the same. User address, cow name, cow ID, and cow breed. If the order of the arguments does not match, an error may occur, or the result received will be incorrect. After successfully invoking the bytecode function, the smart contract will return a custom type. In Flutter, a custom type from Soroban will be received and then parsed as a list containing XDR Soroban contract map entry. We must iterate over this list to get the status, data count, and ownership. We then turn this data into a bytecode result object on the Flutter side, which will be displayed to the user. We have covered a lot of ground diving into the Soroban and Flutter code, and you've been amazing in keeping up. Kudos to you! I hope my explanation of the Cowchain Farm smart contract was clear enough and can help you build your next project using Soroban. Thanks for watching, and happy building with Soroban!